Hey guys, this is Anand Chimpy from AnandTech. We are back with the AnandTech Podcast, episode 10. As promised last time, we are going to do a little bit more of a PC focused episode this week because we had a mobile focused episode previously. Joining us once again, we have Brian Klug, our senior smartphone editor.
Hey guys.
We also have back from the UK, Dr. Ian Cuttress, our senior motherboard editor.
Hey.
And we have special guest Ryan Smith, our senior GPU editor.
Hi, everybody.
So this is actually an awesome group. One, Brian always provides great perspective. Ian and Ryan, great combination here because we are going to talk about Xeon Phi. Ian, I know you do a lot of GPU development, and Ryan obviously understands the GPU market very well. So that'll be an interesting topic to go over the kind of first publicly available or soon to be publicly available version of Larrabee. But before we get to that, I want to talk a bit about Taylorsville, which is the code name for Intel's SSD DC S3700. It's a terrible name, but that is the latest drive that just came out. It's a data center focused drive. We reviewed it on the site. There are a bunch of videos. I actually just got back from SC12 to kind of talk about it and its performance and all that stuff. I'm really excited about this drive because it kind of starts the next era in SSD revolution, or an SSD evolution. So I kind of view the first era as back in 2008. We went from mediocre SSDs that were super expensive, like 15 grand for 32 gigs, or somewhat affordable sub $1,000 MLC SSDs that were just really bad, all the J-Micron stuff. In 2008, Intel came out with X25M, and we had the first reasonably priced $600, but good performing drive. So that was kind of that first era. The next era, in my mind, was this kind of pursuit of random I/O performance. Everyone just now starts talking about IOPS instead of just sequential I/O performance. And the S3700 kind of begins the next phase in the evolution of SATA SSDs, which is a focus on consistent I/O performance. This is something that I kind of, it had always bothered me, just how inconsistent SSDs were from one write to the next. And I don't know, you guys, anyone chime in here, is this something you guys have ever noticed? Have you ever run into that kind of, everything's working fine, but then there's that one pause or hiccup while you're using your system with even a really good SSD? Has anyone else encountered that?
Yes.
With the first SSD I got, it was a 64 gig Samsung, old one. And I'd get to about 80% full, and every hour or two, it would just stop for 30 seconds, then continue on merrily, as if nothing had happened.
So that's a little extreme, right? Like that seems to me like more of a, that was indicative of all of those first generation drives.
Yeah.
And the old Samsung ones were really bad like that as well. Samsung didn't even get into what I would consider recommendable territory until the 470. But Brian, when you say yes, are you talking?
Yeah.
So you've noticed
X25 Gen 1, remember?
Yes.
When we talked about this, that would stall sort of the same way at random for upwards of like 5 to 10 seconds. And you'd see the activity like just come on solid.
Yeah.
And it was like you couldn't do anything. It was just completely IO stopped.
Now, have any of you guys encountered this on any of the modern drives?
I can't say I have. The Intel 520 I'm using right now has been great.
So the 520 actually, all of the SandForce drives, the good ones at least, they are some of the most well-behaved when it comes to I/O consistency. Just because most of the time you're running at very, very low write amplification. And as a result, like if you actually look back at our S3700 review, I had Intel's 330 in there. And the clustering of IOPS, which is basically just another way of looking at consistency of I/O latency, it was most consistent outside of the 3700 on the 330, which is a SandForce drive, just like your 520. So that's interesting, Ryan, that you haven't seen it. That is definitely a plus for SandForce. And Brian, your main system also uses a SandForce drive, right?
Are you talking about the MacBook? The desktop uses Cherryville, which has been solid.
Okay, and again, those are both SandForce drives as well.
Yeah. Oh yeah, you're right. And that's working fine. Although, I don't know, we had some suspicions about the 480 earlier this week in the MacBook, but I mean, who knows what that is? I think that's just OS 10 10.8 degrading slowly.
Yeah, it's Brian was having some issues with Mountain Lion, which I've had tons of issues with Mountain Lion, and I don't. It's interesting because it does seem to vary depending on hardware platform. But when we were talking about the issues, Brian mentioned that he tried to go into the pre-boot environment under OS 10, and his Vertex 3 took a little while to mount. And that to me is always like, whenever a drive takes
alarming.
Whenever a drive takes time to respond to commands that it should respond to right away, I start getting really worried. But
I definitely got worried too. But after like a minute of smashing my head against what is it, HD util, and then the little disk utility like GUI tool, I was some combination of things / just the minutes that passed made it finally mount.
Because what happens with a lot of these SSDs, right? They have, if you look at the physical boards, right, they have this little bit of like SPI flash, right, and that's their boot environment. All of that gets preloaded and cached into DRAM, and things go on their way. The problem is if something fails during that process, during that boot process, at least on a PC, you have like a BIOS or a UEFI or something you can interact with. Here, it's all internal to the drive, and the drive doesn't always have a way of telling you what's wrong, right? So everyone, if you've ever had an Intel SSD or an Intel controller SSD, they all have that. You search Intel, SSD 8 megabyte bug. That's Intel's failure mode, right? So if there's any issue with loading its kind of real-time OS, if there's any issue at all, it defaults into a state where the drive just appears as an 8 megabyte drive, right? That you can't get access to anything. That is its effectively its pre-boot environment. Now, it goes in that environment for like one of a billion different reasons, which is why the bug always looks like it's something that's far worse than it actually is. But that's the frustration with all of this. Intel has that in mode that it goes into, but a lot of these drives, they don't have any publicly visible mode that they go into. They just stop responding. And there's no way, unless you connect to the debug port on the drive, to really know what's going on. But Ian, what SSD do you use in your main system?
At the minute, I have two Vertex 3 240s in a RAID 0 configuration.
Okay, so all of you guys have kind of the best drives for I/O consistency to begin with. I'm curious how much.
Well, you gave them to us, so
how
you better not have cheaped out.
How much spare area do you guys keep on your drives, Ian? How much room do you have on yours?
Well, my system's a relatively new build, so it's got most of it free.
Okay.
But my netbook, I've actually taken it down in terms of space down to megabytes, and it's come back, and it still gives me the same feel. When I free up another few gigabytes, it still gives me the same feel as when it was new.
Interesting.
When I put it in.
And what drive is in that?
I can't remember. It's a small one. It's a small old one. But I mean, it's all very well quoting numbers to say drives, back at full performance.
Yeah.
On a consumer level, somebody like my father, as long as it responds as he wants, that's good enough for that level.
Yeah, I mean, from my perspective, it's like we're all bound by 6 gig SATA for the foreseeable future until we move to SATA Express. So what are the vectors of improvement, right? People aren't just going to say, hey, we're not going to release any new SSDs. There's been this kind of race to get closer and closer to, I guess, peak random I/O. But for a lot of client usages, I think we're saturated in terms of how much random I/O we really need. What I would rather have is more of that kind of I/O to I/O consistency, which I see a lot of under OS 10. Like Mac OS doesn't respond well at all to I/O latency. And I've been doing a lot of my kind of OS 10 testing and usability testing on non-SandForce products, right? Because I think still there are a lot of folks that are just not okay with SandForce, and I've been kind of on this hunt to find good alternatives. And when you don't have real-time compression, when you do effectively have the amount of spare area that you have that's it. That's where I start seeing like a lot of these hiccups, a lot of these kind of variances from one I/O to the next. And it's not debilitating like it used to be a few years ago, but it's still annoying, right? It's when I always say that the only thing that's more frustrating than something that's slow is something that's inconsistently fast. And that's what I see with a lot of these SSDs. And that's what the 3700 tries to address. The downside is it tries to address it just for the data center market. But my hope is that now that stake's in the ground, that we will see this kind of go top to bottom, or at least mostly top to bottom. And no one's still really taking the embedded tablet space very seriously in terms of having good controllers. But other than that, I have high hopes for the technology, at least.
I'm at 60% free, by the way, on the Vertex 3.
That's good. I'm always running I usually get an out of space error.
Really?
I'm also really bad about, I don't know, cleaning up my storage and making sure I don't have extra duplicates of stuff. I can usually, whenever I run into that error, I can usually quickly free up about 10%. But I found especially, I really like the Samsung drives, like the 830 and all of that. And I find especially on that drive, if you get within 10% of max capacity, you run into issues really quickly. It's not bad, but you just start noticing that the drive takes longer to respond. That even things like switching between apps, there might be a little pause or something there.
Huh. I mean, that's not acceptable, right? You sold a drive that's certain capacity. I think the user should have an expectation of performance is going to be constant over the whole thing.
Yeah, but
even though with hard drives it's not even constant.
Exactly. It is still it's nowhere near as bad as a hard drive, right? On a hard drive, you fill up a hard drive with through actual use, and it's just miserable by the end of it.
Yeah, it is painful.
I have an old laptop with a mechanical where the USB 2 ports are faster than the drive.
That's terrible.
That's pretty slow.
I did a Crystal Mark test on it, and sequential.
Well, is it IDE inside or something? It's like an IDE to USB 2 controller.
It's the laptop's about 7 years old and it overheats. Oh no, it idles at about 100 Celsius.
That's terrible.
I think you might have some thermal issues.
I don't use it anymore. Anand,
when you just abuse it.
Yeah. So Anand, when you're saying that when you hit the limit, you instantly find that you can take about 10% off. Is that just transferring stuff to the NAS or just doing a general cleanup? If so, what sort of cleanup software do you end up using just to take out temp files and stuff?
No, it's not even temp files. It's stuff I've downloaded and that I have my workflow ends up being on my main machine. Someone will send me a driver package, or they'll send me something they want me to look at, like a huge presentation or some video files or a bunch of photos or something. So I'll take them, look at them, and then I'll copy them over to the NAS. I rarely just move them over to the NAS because the NAS doesn't come with me when I take my notebook with me. So it's helpful to have that stuff there. But usually I can, there's at any given time probably 10 gigs worth of stuff that I just have in my downloads folder that I can delete and be okay with.
I'm not sure if you've come across a program called CCleaner.
No, I haven't.
CCleaner?
Yeah. In Windows,
I love CCleaner.
It's a nice little program. It takes out old registry entries and just cleans up the drive nicely.
That's an oldie.
Hey, every time I open it, it still asks, "Do I want to update to the newest version?" So it's being updated constantly.
Oh, that's good. No, I've never used it. I'll give it a look.
The C in CCleaner stands for crap, right?
Yeah.
And this is Brian's insight. Okay, all right. That takes care of the SSD discussion.
Anand,
yeah.
So, do you keep all your photos when you're doing photos? Because this is a big part of all of our lives is taking tons of photos of everything.
Yes.
Do you store them? I'd imagine that's a huge chunk of your space. Like the hybrid drive, Momentous XT, that thing is all dedicated to photos.
So I don't store the raw files of all the photos, but I do store all of the whatever I export, all the JPEGs.
Gotcha.
I store those. I tried storing at one point I had this idea that hey, I'm going to store the originals of everything I shoot, and that quickly made it so that I couldn't like use modern platforms because like it's
you could never use your computer. It would just always be full.
yeah, there's no way to get around that. So I was like, hey, look, high res JPEGs are okay.
Yeah. Every so often, I just do a bulk transfer of everything that's sort of like more than 2 months old down to 920 by 1080.
Yeah.
Software that selects a directory and then goes all of them transform, resize.
I just export the Lightroom library to the RAID 5, and then I start a new one.
Oh, interesting. Yeah, I have a problem right now where I have a bunch of independent Lightroom libraries, and I know one of them. My biggest fear is that it's going to accidentally get deleted because it has photos from a project that I've been working on for like the past year. We haven't like publicly talked about it, but like the K20 article, and like those photos, I can't recreate those because of the time. Like they were from a specific event that I can't recreate, and that's in some Lightroom library somewhere that I need to find in short order.
Okay. Interesting.
Okay, so speaking of kind of big GPUs, Intel, I don't know if would you guys characterize it as a quiet launch? I can't really gauge because like around the web, no one really talked about it, but everyone in the HPC community was talking about it. Xeon Phi. I was there on the floor at SC12. What did it sound like to you guys? Was Xeon Phi making a lot of splash on the web when it hit?
Not at all. You basically had to be paying attention to the HPC space.
I think the name changing it from what used to be Larrabee, when people mention Larrabee, they knew what you were talking about. Now you say Xeon Phi, and it doesn't generate much of a response anymore.
So,
yeah.
What's interesting is, you go back to 2008, 2009, you mentioned Larrabee, and I mean, I remember being in meetings with AMD and NVIDIA, and there were some folks that were concerned, like, hey, Intel's getting into the high-end GPU market. We have a lot of reason to worry. Even though, there were folks in those meetings that were like, hey, look, this technology doesn't make sense to us. There was still cause for concern kind of across the board there. Whereas now it's like, the thing launches and, it's got some attention within this like niche community. But outside of that, it's Larrabee's kind of forgotten. And it's, I don't know, it's interesting to me. I don't know if we've ever talked about this publicly, but the reason Larrabee got canned as a GPU project was originally Larrabee was supposed to be the graphics core that got integrated into Haswell. And it was actually the Haswell teams that said, because if you integrate a core that doesn't work, or if you integrate graphics or GPU that's going to be problematic into a CPU, now it potentially disrupts everything, right? You have a situation where Intel might have an entire year worth of CPUs that they can't sell because the graphics just isn't competitive, or it's too power hungry, or what have you. So it was actually the Haswell team that looked at the GPU that was being integrated, and they were like, hey, look, some of these numbers don't add up. I don't know if we want to integrate this. And it was actually their findings that then got fed back into the Larrabee GPU team, and that started the process that ended up getting that thing canned. So that was always super interesting to me.
Well, that all had to make that decision 3 years ago, so there's no way you could predict what the final outcome of the Larrabee, what is now Xeon Phi, would have been.
Yeah, it's and Ryan, I'm curious your thoughts on this. Why do you think Larrabee failed? I know the kind of prevailing wisdom is, look, you just don't turn certain things that should be fixed function into completely software programmable. But is that your take as well?
Yeah, that would basically be my take. Intel had some very interesting, very ambitious plans for it. A big part of me would have liked to see it play out. But what they're proposing was putting a lot of graphical rendering into basically into their shader cores in GPU parlance, as opposed to having fixed function hardware. Typically in a GPU, we'd have fixed function ROPs, TMUs, geometry setup, etc.
Now, from your perspective, is there hope at all for the architecture, right? Like, would a Larrabee that kind of leverage some fixed function hardware, because presumably it's not that hard to add fixed function hardware to this array of x86 cores, would that have any potential or hope in the market?
We're so early into Xeon Phi. It's hard to say. There's a lot of work, even adding fixed function hardware. Mainly how you go about routing all those connections, making sure everything gets fed in a speedily enough manner. But sure, if the Xeon Phi's uh, processing architecture works out, then I don't see why you couldn't build a GPU off of it.
So at a high level, the kind of Xeon Phi card that got launched, the Larrabee chip itself, Knight's Corner, I guess is what it's called. It's a 22 nanometer, 5 billion transistor chip. The thing is huge. It's got somewhere around 60 in order x86 cores that were loosely derived from the original Pentium. These cores all run at around a gigahertz, and they are fed by they've all got a 512K local L2 cache. There's a big ring bus that connects them all together. It's like a super interesting architecture. All of this is down on a PCI Express card, a Gen 2 card. And the beefy Xeon Phi, the 5100 series, has a 512-bit memory interface to 5-ish gigahertz GDDR5 with, I think, 8 gigs per card. And so that's one version of it. They also have another version of it, the 3100 series, that'll launch next year, the first half of next year. Core count is unannounced, but somewhere around that 60 core number. Frequencies will likely be significantly higher. Memory bus interface goes down to 384 bits with 6 gigs of memory. So this is more of a compute focused card, whereas the 5100 series is more memory bandwidth focused. And Intel's promising at least a teraflop of double precision floating point performance. So, Ryan, that doesn't sound like a lot. You've covered obviously all the high-end GPUs. Where are they at in terms of double precision floating point performance, roughly?
So their competition would be NVIDIA's recently launched K20, which right now K20X has a theoretical double precision performance of 1.3 teraflops, making it, well, on paper, the fastest such card right now. And then you have AMD's cards, the recently announced S10000, which is a pair of Tahiti GPUs that would have 1.4 on paper, and then their single GPU variant, the S9000, is at about 900 gigaflops.
So 1.3-ish, 1.4-ish, you're looking at 30-40% peak theoretical advantage here. That's actually not that big of a gap because I don't know what the pricing is like on the AMD solution, but at least compared to K20 and K20X, Xeon Phi is appreciably cheaper, right? Like Intel's talking sub $2,000 for a 3100 series card, and like what, $2,700 for the 5100 series card versus almost $4,000 for the K20.
Yeah, K20 cards start at $3,200. That's for the K20 itself, and then NVIDIA won't even give me a price on the K20X. It's somewhere in the $3,000 to $5,000 range, depending on how much markup your OEM decides to tack on. But
Okay.
yeah, so NVIDIA is definitely the most expensive solution this time around. AMD is like $3,500 for the S10000. The S9000 is significantly cheaper.
So I'm curious, is this this actually reminds me a lot of the enterprise SSD space, where Intel comes out with the S3700. This is like an eMLC or MLC with MLC het, like a high endurance drive. They come in and they're like, we're going to charge a premium for this drive, and they're in at $2.35 per gigabyte, which is nothing for an enterprise drive. This sounds very similar here. Why is Intel able to be so cost competitive here? Is this purely because they're fabbing it at their own fabs and they have the capacity to spare?
I'm sure that plays part of it. 5 billion transistors at 22 nanometers versus 7.1 billion transistors at 28 nanometers. That's going to play a big part right there. We don't have the die size measurements for the GK110 GPU, but certainly north of 500 millimeters squared. So yeah, that's going to play a big part. It also is going to be Intel needs to leverage themselves into a market that, well, right now NVIDIA actually has a good grip on. GPUs are still relatively new into the high performance computing market, but for what there is, it's largely NVIDIA.
Yeah, and you and I were talking about this recently. You think Kepler and K20 and K20X might be what it finally takes for NVIDIA to take its HPC business into the kind of billion-dollar territory.
Yeah, as I put in our little review there of K20, and the enthusiasm coming out of NVIDIA, it's not your normal PR enthusiasm. It's very real. You see that same enthusiasm, sort of infectious, being radiated out of the HPC community, being radiated out of NVIDIA's user base. It's not like K20 is a massive departure in terms of functionality from what Fermi could already do, but just NVIDIA's gotten their software stack to the point where it's going to really work well with what their HPC customers are looking for. They've added these few extra features here and there, like HyperQ that map well to the MPI standard, etc. So I think this is finally going to be it.
So, Ian, you have a lot of CUDA experience. Things like HyperQ, all of the new Kepler K20 features. Any of these resonate with the kind of work you do on GPU compute?
My background's more sort of OpenMP style, sort of single machine. Run as many threads as you can.
Okay.
So the basic CUDA functions is great for that. One of the things I think Xeon Phi is probably gonna make wins on is that individual compute machine. The researcher who wants a supercomputer under his desk, if he can easily port his OpenMP code into that, drag and drop, then there's a lot of potential in that area. Plus, the Xeon Phi top-end cards pack in 8 gigabytes per card, which is a third more than the K20X. And there are a lot of applications where having that memory on the card really does help. Everybody's pushing for more.
Interesting. Yeah, and that's really, when I was sitting at the Xeon Phi briefing, Intel was really viewing this as a migration for those who already have x86 code that they're working on, and they happen to have code that would run really well on this kind of massively parallel architecture. You go out, you buy a Xeon Phi, and without any real effort at all, you can just run that code on this card because it's all still x86. Now, you don't have, look, if your code's got SSE in it or AVX and all that, that's not going to work, right? Like this is, there's Xeon Phi has its own kind of vector format, which was actually heavily influenced by a lot of the game developers back when Larrabee was being built. So, there's some room that you have to do some work to kind of get it operating at peak performance. But the idea here is that you have your x86 code. If you have code that, really maps well to this like massively parallel, tons of little cores kind of architecture, well, you just run it on the Phi. And whereas NVIDIA still has to kind of convince you to, look, you need to take that extra step and go and develop in CUDA. And that's how you can extract the parallelism out of your GPU. Which still isn't bad. Like obviously we've seen lots of success stories from it, but I think if you can offer even fewer barriers to kind of porting your code over there, there's a lot of room for success.
Well, when it came to me learning CUDA, coming from just programming basic code on a CPU, you have to develop the mindset of the architecture in order to be able to rewrite your code.
Yes.
So with the CPU, when you've got many cores, you have to have Snoop protocols, so each core knows what each one is doing. And then when you move to the NVIDIA GPU, each of the units assumes that it's got its own workload to do and doesn't need to worry about what everybody else is doing. The Xeon Phi seems to take more from the CPU side, especially because each of those cores has its own L2 cache on the ring bus, then back to main memory, whereas the NVIDIA GPUs just has the L2 cache for the whole chip.
Yeah.
So if in the reasons where you've got simulations which require each thread essentially to have that half a meg of instantaneous data, then Xeon Phi is going to be the winner because that's where the quick read and write store is going to be. Try and do that on a CUDA card and you'll end up accessing out to main memory too much.
Interesting.
At the same time there's a lot of talk about how this is x86, but I think you need to also really look at the fact that NVIDIA and CUDA have all these language bindings for every other language already. And to someone like me that's not going to go do something a level, that's awesome. Like back, I had a friend who was doing all sorts of solidification simulation in CUDA, and I look in Python with CUDA bindings. Like you just use PyCUDA or something.
Yeah.
Yep.
And I believe that's what he was using. And when I looked at his code, I was like, wow, I could do this. Like just no problem.
Oh,
And I mean, like as soon as if Xeon Phi gets there, then that's one thing, right? But now they're kind of entrant, and that's probably why you see the pricing being what it is. And they just want all of that. It needs to happen. The whole ecosystem.
But to take the situation where you're a scientist, you may not know that much programming, and you're told to write a simulation. So you go back to the textbooks, chapter 1, how to write a program, chapter 2, multi-threading, or chapter 13 will be multi-threading. And by that time, you may have got a sort of inkling for classes, deriving your own functions. And then the minute you can put OpenMP on that, you can slap it on a Xeon Phi. To get it onto CUDA requires that paradigm shift in the way of thinking of how you're going to compute what you're doing.
Yeah, I mean, unless you like lazily throw it at like what I would do, just lazily throw it at here. These functions are gonna work. Just go off and do it. I mean, yeah, you can just spawn workers and execute them on Phi, I guess is what you're saying. What's interesting to me is that they have all these different execution models. And I really wonder how much of that is like, oh, well, we need it to work now, guys. Like how much of this is like it's still a GPU architecture that's fundamentally being repurposed for, high performance compute?
Well, so
versus like which of those do you design to? That's what I really wonder is at what point is it better to have something that's completely redesigned for we're going to do high performance compute versus I just want to know what all the caveats are.
So what's interesting is the when I was doing the Oak Ridge stuff, I was sitting down with some of the researchers there, and they were like, look, this is all the stuff that we're using today. We only have it because the gaming industry allowed us to have it, right? Like people built these amazing GPUs to run games, and it just so happens that our problems are very similar in nature. I think over this past generation, or maybe the past 2 generations, we really saw kind of a lot of folks building HPC specific or kind of high performance compute specific hardware. But other than that, we've always just been using commodity hardware here, and that's why I went into this. That's where I think that they went in and they built something that could really be used for both. From their perspective, the x86 side, I think it targets to a different audience, right? I don't think you're going to convert anyone back. The people that have invested millions in building these kind of CUDA-based supercomputers, I think they're just going to stay there. But really, for everyone who is kind of on the verge of needing more of a performance boost, and they don't want to have to rethink everything, right? They just want to take their existing code and then just retarget it on a different platform without refactoring the way they do loops or the way they handle data accesses and stuff like that. They just want to take it and run it on something else. That's where I see the opportunity in Xeon Phi. But you bring up a great point. Like there's this huge barrier to kind of being the NVIDIA replacement, in that if you've already made that transition to NVIDIA, I don't know that there's necessarily a reason for you to go back and give Xeon Phi like a consideration.
Yeah. Were you saying, does it have Linux support?
Yes, it's actually Xeon Phi.
It's native. That's what it was. Okay.
Yeah, the card itself runs a custom Linux kernel, and then the card is only supported under Linux at this point.
Gotcha.
Interesting.
I couldn't remember if it was Windows that you said that it wasn't supported or Linux.
Yeah, no, it doesn't. No Windows support as of yet.
Interesting usage scenario is when I was learning CUDA, the guy that was teaching was mathematical finance, dealing with sort of Black-Scholes type of predictions, and even more complicated than that. he told of a story about how he was trying to get quantitative analysts, into CUDA, because the sort of stuff they're doing, you're just talking about peak random number generation. How many random numbers can you make per second on your hardware? And he was struggling to convince that CUDA was the right way to go, even though it required rewriting algorithms on different hardware.
Yeah.
I think with Xeon Phi, with just the ability to open MP port, could really help in that situation. Drop in a card. There you go. Put an extra command in your code, and off you go.
Yeah. I want to see things like MATLAB support. Like, honestly, that's what it needs for me. MATLAB, Python.
Well, see,
doesn't MATLAB or Mathematica already do a lot of CUDA functions if you get the modules in?
That's the parallel computing toolbox in MATLAB does do CUDA. I'm talking about I want MATLAB parallel computing toolbox to work with Phi.
Well, so that brings up a separate point, though. For that type of a usage model, you can just go buy like a $300 consumer card, and I don't see Intel.
Yeah.
Like, that might have been an original target for Larrabee, right? They might have been targeting $199 and $299 as a price point. But
this is true. This is like something way beyond that.
Yeah.
Then this is like how is this going to be sold? No retail channels. This is going to be like you need to go ask. But I mean, that's the way that market works, right? Like, I'm not going to walk into a Fry's and buy a Tesla.
Well, so
you can in the UK e-tailers. They sell Quadro and Tesla cards.
Yeah, I think when the 3100 is available, you'll be able to go through whatever your channel distributor is and get one of these cards. Today, if you are running a supercomputing installation, then I'm sure you have access to it. Otherwise, yeah, you kind of have to wait a little bit.
Yeah, give it another 6 months to filter into retail.
Yeah. But yeah, I think, Brian, for the, and I think that's a very valid point, right? The rule of thumb has always been, you can't exist solely in the high end, right? You need to have kind of this mainstream base that you can use to subsidize the development of these high end architectures. And ultimately, I think Intel does need to have a solution for this like $300 true supercomputer under your desk, but on a budget kind of market.
Because that's what all those scientists do. Like, the people that I know in materials science, people I know in optics, they just bought like a bunch of, like, one guy, literally I built a computer for him that I think we had like 4 590s, I want to say. GTX 590, 580, whatever the like two card together NVIDIA thing was at the time.
Yeah,
590.
For 4 and 5 in one machine.
Yeah, it was 4.
Windows 7 only supports 7 GPUs.
No, he only does Ubuntu. So he didn't even have he only had graphics connected to 1. Like, he was like, I don't even care. I'm just gonna run CUDA and all my stuff on this.
Sold them all.
Yeah. Mm-hmm. I was concerned that it might not, but it did.
But so
it wouldn't under a Windows system anyway.
Yeah, that's why he didn't use Windows. Well, he doesn't use Windows because he doesn't like Windows. and for a while I was colored by him and only used Ubuntu as well. But
so in like, now for that kind of user, that's kind of extreme, because you're almost at that same like $3,000 price point.
Well, he was just spending his grant money.
Yeah, I gotcha.
Like, he was like, I need to spend all my grant money, like, just put everything possible into this box.
Well, that's also another thing. If you're a PhD student and you're getting data, sometimes ECC memory isn't needed. Some of the stuff I did based on random numbers, ECC was never an issue. But when you go into big supercomputing and nuclear type simulations, you really want to be running ECC. So that would have blown the grant money to sky high.
Yeah, and that's what I remember when we were first talking to NVIDIA about Fermi. They were basically like, look, a number of customers, like, we won't even get a meeting with them if we don't have ECC on our DRAM. And you look at it, they weren't lying, right? Like, when I met with the folks at Oak Ridge, they were like, ECC is necessary. We have 18,000 of these things in our one supercomputer. Like, we need ECC has to be on everything.
I think the current rate of bit errors is 1 per year per gigabyte.
1 per year per gigabyte.
With ECC on?
That as in
With
just
it off.
standard memory will get 1 error. I mean, the production has gotten good with memory that it's just 1 per gigabyte per year, which is enough to throw a simulation off whack if you don't have ECC and you're running it for months.
Huh.
Well, it's just a function of you have so many GPUs, you're just increasing your surface area for failure.
Yeah.
So it's not surprising that.
So if your simulation is going to end up with 1 bit error an hour, you got to have the ECC.
Yeah, that makes sense.
Yeah, it also comes down to having ECC not only on the DRAM but on the internal data pathways too. That's one of the big things that separates K10 from K20 is that K20 is built from the GK110 GPU, so it has ECC on all those internal paths. K10 only has external ECC on the DRAM because the GPU was never meant for it.
Interesting. What GPU is K10 based off of again?
GK104, same GPU that's in the GeForce GTX 680.
Okay, I gotcha. It's crazy stuff. So that's one end of the market. One end of the market that, if you pay attention to this entire conversation, AMD tends to be mostly absent from HPC discussions, although they're trying to change that. They
made a huge change on that. Granted, they only have one computer in the top 500 list, but that's a breakthrough for AMD right there.
Yeah. So, do you believe, Ryan, like they consciously didn't pay this kind of compute penalty years ago, and as a result, looked better in the consumer market for a considerable amount of time versus Nvidia? Do you now, looking back, do you believe that was the right decision?
Good question. I think that AMD came out with Graphics Core Next at a time when they could. I really don't think it was an option for them in terms of their development capabilities, development cycles, to come up with something like GTN significantly before when they did.
Why is that?
Just the amount of time it takes, the amount of experience you need.
But that was a priority on their point, right? They said, look, we're not going to prioritize compute until it makes sense, and GCN is when it made sense for them. Assuming that, and they benefited handsomely for it, right? Like Nvidia went down this compute path, and for the first couple of years there, or the first couple of generations there, it didn't look good for Nvidia. It wasn't really until Kepler that things all clicked. And really, at Kepler was when they kind of diverged from that strategy and brought a less compute-focused GPU to the market in order to kind of fix that problem. But and now NVIDIA's on the verge of this kind of billion-dollar business with HPC and what it's doing with Kepler. So I guess the question is, had AMD made the same exact decision that NVIDIA did and focused on that and said, hey, look, we're going to prioritize compute, do you believe that they would have been in a better position today?
Oh, absolutely. I don't think there's any question about that.
So AMD made, by winning all of those consumer battles, AMD actually kind of made the wrong decision in your eyes.
If AMD wanted to have a big part in the HPC compute market, waiting until they did, yes, was a mistake.
As a company-wide decision, though, was that a mistake?
Company-wide, well, at least up until recently, AMD's focus had been on HSA Fusion. So, no, I don't think it necessarily would have been a mistake company-wide, because they needed these more graphics-oriented cores as part of their roadmap to build out their APUs and build out Fusion. I mean, GCN, if we were talking about using something GCN based on Trinity, for example, you're effectively talking about a part that would offer lower graphics performance. At that point, where's AMD's advantage in the market?
Interesting. So, if I'm understanding you correctly, you're saying that pursuing kind of the compute-focused core would have made all of AMD's client-focused APUs a lot less interesting, a lot less competitive.
I wouldn't say a lot less. I would say that there is a very obvious performance trade-off when you pursue compute. You have to give up some space that you would normally throw in extra graphics hardware in order to throw in whatever it is, ECC hardware, additional cache, additional instructions that really only benefit compute, etc.
I guess what I'm getting at is, and this is kind of the topic, the next portion of the discussion here, is AMD is in a very worrisome position now in the market, right? It used to be, for the past several years, AMD just used to be the player that couldn't make a whole ton of money. But now we're discussing, at least publicly, a lot of people are discussing this idea that AMD might no longer exist as an independent entity.
Okay, can I butt in with just a small thing back about the HPC?
Yeah.
Because I take a different point on it with regard to AMD. They've had the hardware all along, HPC. I think it's the software side which really came crashing down on them, and so they didn't get into that market. So when CUDA was in its sort of first and second generation, NVIDIA released a higher level language to complement the low level, and unless you were an enthusiastic computer science student really into your software, then that group of people would love the low level language. But as a casual scientist, having the high level CUDA language really helped when it came to transferring my simulations from CPU to CUDA. What AMD didn't do with their close to metal and other stuff that they had, the name escapes me, but it was all low level. And there were certain applications where using the VLIW5 and VLIW4 really helped. Any listeners who do a bit of Boink will know that the Milky Way at Home project really, they had a couple of developers that took their code, made it into all the low-level AMD stuff, and it flew. I mean, we're talking hundreds, thousands times speed up using an AMD card over a CPU. And the code was, the algorithms were better fit for the AMD cards than the NVIDIA cards. But it's the fact that they had people on hand, willing volunteers to transfer that code into the low-level AMD code, which made that project and made the science in the area fly. If AMD had spent considerable time and resources developing that higher level language, I think a lot more people would have taken it up.
Yeah, no, that's I definitely agree, right? Like this wasn't just a hardware issue. NVIDIA, we used to complain about how hard they were pushing CUDA on everyone, but that is, I mean, to their credit, that's a big part of why they were able to be successful kind of ahead of the curve with GPU compute. And AMD they were never as aggressive there. I think AMD was hoping that Intel and the rest of the industry would kind of come forward with a more open standard that everyone would just adopt. And I don't think that the rest of the market was just there in time. And thus...
Sorry. No, Ian, it's an interesting point because it seems like everything that I looked at was also the same way, right? Where AMD had a huge performance advantage when someone finally went in and decided let's dedicate it to the low level, low level language like Pirate, like Bitcoin mining. I mean, the list goes on and
there's
on.
A very
it was
specific
like everything
reason for that.
was tailor made to VLIW5.
It's a specific hardware reason for that. That's not really about software. In the case of Bitcoin, a couple other things, we're talking about uses that map very well to what was very simple compute hardware.
To VLIW5, yes. Right? And transcendental function units that they had?
Exactly. It was...
yes.
It was
if you had the right equations, the right algorithms for that hardware, then it worked great. But there was still the barrier of being able to know the low level.
Right. Yeah.
So otherwise you just say, well, rather than spend 2 years learning the low level and stuff that I'm not entirely too sure about, I'll just go the higher level and take a slight performance hit using NVIDIA. So go out and buy an NVIDIA card.
And at the hardware level, things like the VLIW5 architecture just weren't that flexible. I won't go into it too much here, but there were a lot of idiosyncrasies in that design that just didn't work very well with the kind of compute applications that a lot of HPC users were actually using. So AMD ended up being very fast at a very small subset of use cases, but they had no performance to speak of everywhere else.
I think a lot more people have tried, and a lot more data points would have got if they had a high level language, even with the hardware.
Yeah, having a higher level language would have benefited them. I'm not saying it's only hardware; it's a mixture of both hardware and software.
Sure.
I'm just saying it's interesting that, I mean, we can't just totally discount all of AMD's efforts. Like, it's not like they completely just disregarded this, right? For a while, it was everybody wanted the AMD cards, for those applications. I mean, remember, it was just like selling cards everywhere. I remember there were some forums where people just had like armfuls of AMD cards.
Well, it's like folding. That's been optimized on the low level CUDA, and the algorithms work better on the NVIDIA cards than the AMD cards. So people who wanted to fold, they went out and they bought 32 GTX 295s or whatever 580s, 480s, depending on when they bought them, and they sometimes they cleared out Newegg in buying them. It's true. There was a guy who had a family member die from Huntington's, and it just so happened that was what the Stanford team were looking at the time. So he built 2 or 3 server racks, each with 4 GTX 295s on it. Had to have custom power lines into his house. Posted the videos and pictures all online, and people wondered why there were no 295s on Newegg for a week or two.
See, I feel like it's a bit in reverse, right? AMD had such good pricing and they had such competitive consumer cards that people then looked at, hey, these things actually also happen to be great for compute. And that's what helped really spawn all of that. Versus NVIDIA was kind of laying this foundation work for an entirely new business segment for them. And thus people weren't as excited about what these cards were doing on their client systems, and thus they didn't just have them laying around to use for some of these other projects, which AMD lent itself very well to be used for.
I'm currently looking at an OpenCL textbook, which is this is something I bought, and I thought I should learn this. Up until about page 12, when they're talking all about hardware, it's fine. I understand the hardware side. When it gets into the code and I see a function to create a stream which requires 3 or 4 different flags, which I don't know what they mean, but I must put zeros and I must put nulls here. It gets confusing.
OpenCL has been a disappointment so far, both from the development perspective and from the use perspective. It just hasn't gained a lot of traction. I don't know if that's because it's too low level or what.
You're talking about OpenCL?
Yes.
Yeah, I mean, and it seems like to me that's what AMD was really banking on happening, right? That OpenCL would kind of be its CUDA.
Yeah, that's exactly where they went. I forget which AMD executive I was talking to in 2009. It was at the Radeon 5000 launch. They were talking all about how everything on their GPU compute was going to be OpenCL now. I asked them, what about your lower level stuff like Cal? And they said that had basically been depreciated from their point of view. That they were going all in on OpenCL.
Anytime I see numbers come out of somebody who's developed, on the OpenCL platform, they're always amazing compared to what they used to do on CPUs. But anything moving onto a GPU is, you always see an increase as long as the algorithm's correct. But I'm much wanting the software to be high level. A, because I'm lazy, and B, because I think there's more people who's going to adopt it. And with Xeon Phi just going OpenMP, it's gonna lift Intel's sales, I think, for anybody who hasn't already gone the GPU route.
Yeah, I think it's purely for exactly as you described it, the existing x86 Xeon developers that have not yet jumped to CUDA. I think this provides them an easy migration path, especially if they're already doing multi-thread development for multi-core Xeons. But the aspect of AMD that I wanted to talk about is kind of what we started with, which is AMD stock is not doing well. Ryan, I think you said they've now hit their lowest point in modern AMD history.
They're very close to it. I have it up right now. They closed at $1.86. Just going through their Google history here, their lowest point in recent history was in November of 2008 during the financial meltdown, when they were at like $1.82. So they're ever so slightly above that. If they fall below that, they're going to be at their lowest level since at least 1990. But
That's
I mean, there's more to life than stock prices, of course, but that just gives you an idea of how dire things are overall for AMD. AMD's always been the underdog. They've always had an uphill battle, but I think this is the first time, as long as we've been in the business, where we're actually talking about the possibility of there not being an AMD.
and Ryan, you've been kind of following this very closely. How likely do you think that is?
Oh boy. On the one hand, I don't want to be a doomsayer, because that's very easy to do. A lot of people like to do it. On the other hand, AMD's in a very bad position. I mean, there's just no getting around this. Trinity sales have been a disappointment, to say the least. They've lost almost all of their server markets. They've given up everything they've gained since 2003. Their GPU business is still doing well, but their GPU business, of course, it just one small fraction of the company. Most of their money, in terms of revenue, comes from CPUs.
Yeah, and obviously, whatever strength they used to have in the desktop market, that's very, very gone. They do have some niche advantages. You look at, if you do need a heavily threaded integer machine and you don't care about power, at certain price points, they are better. But that's just a tough recommendation to make across the board. And if we see the desktop CPU market as being relatively flat, and with a lot of people going in and exploring ultra mobile options, or that transition to notebooks, if Trinity's not doing as well, this is all not good for AMD on the CPU side.
Yeah, so that's another thing that's going on. Talking about AMD here, Intel and Nvidia are also near 52-week lows. Investors have just kind of gone sour on everything related to the PC right now. It's probably an overreaction, grass is green on the other side kind of thing, but it comes at a very bad time for AMD.
How are Microsoft and Apple on 52 weeks? Trying to gauge whether it's industry or just based on the PC component.
Or the election.
Apple's
elephant in the room there.
Apple's nowhere near their 52-week low, but they're also well off their highs. They've lost probably about 20% here, but down to 527 with their peak. Their peak was almost $700. As for Microsoft, let me pull that up. Microsoft is only slightly above their 52-week low, $26 and change, with a 52-week low of $24.
So the fact that the whole industry is sort of on that 52-week low, is that just not? Are we making a mountain out of a molehill with AMD?
Well, so we should clarify. Apple's 52-week low was 363, and they're at 527. So their high was 705. So they're definitely way off the high, but they're not quite at the low yet.
Yeah, what's going on with Apple is entirely different than everyone else. Apple's going down because investors think that they can't maintain their momentum, and they're going to lose some of their phone and tablet share to the likes of Samsung. Everyone else here, it's exposure to the PC market, where investors think that all of this is doomed because the market's flat instead of growing. But for AMD, this isn't the cause of AMD's problems. This is just one bad factor in terms of many things going on.
So,
well, Nvidia has the mobile SoC space, right? That's the exit strategy if the PC market just kind of dries up. Which is, I mean, you can plot a slope, and it's obvious that it's a negative slope, right? So AMD has nothing except for hey, you sold your GPU assets to Qualcomm. That was a bad move, right? I mean, I'm just being honest. That's the reality.
Yeah, I mean, so the issue with Nvidia, right, is it's an interesting story with Nvidia, because if you look at, well, where did the Tegra team come from? The Tegra team came from the old NVIDIA chipset team. Well, why did the chipset team stop making chipsets and go to build Tegra? It's because Intel stopped giving the chipset team licenses to the Intel FSBs and to QPI and all the future Intel interconnects. So Jensen took that team and said, look, we can't make chipsets anymore. Intel's kind of pushing us out of this industry. But this is going to be a great opportunity, right? The entire team was like devastated. And Jensen said, no, this is the best thing that'll ever happen to us because we don't need to make these stupid chipsets anymore. We can do this stuff that's going to matter a lot more in the future. And that's where Tegra came from, which is really interesting because if you think about from Intel's perspective, what would have been better for Intel? To have another strong ARM competitor or someone that's just going to make third-party chipsets. And I have to believe that someone just making third-party chipsets would have been a better long-term strategy, right? If you had just continued to give NVIDIA license to build this stuff, Tegra wouldn't have happened unless NVIDIA built an entirely separate team. But if they're making good money off of these things, there's kind of no motivation. And then they would have ended up in a very similar situation, at least with not having a significant mobile presence as AMD does today.
But I remember AMD was making chipsets too. When they pulled out, it's not like they immediately started making SoCs. I mean, it takes. There was obviously a lot of vision, and this is where the market is going. And I think it takes a lot to realize, hey, we're making a lot of money making enthusiast GPUs. We're making a lot of money making like mid-range and smaller, lower end DGPUs that go into products. To mitigate the terrible, awful badness that is the Intel integrated graphics. Intel's getting serious about Intel integrated graphics. What's the mitigation? We go and make something else, right? I think at a high level, you can really easily, like connect those dots.
No, that's very true. Jensen, for better or worse, as much crap as people give him, I don't know of any other CEO that's been with their company for this long, in the tech industry. And has still been able to execute this well. I think you're very, very right. Like he definitely had a lot of vision there. And that's something that the AMD folks, I understood their panic, right? When they sold everything off, when they, the idea was similar to what Intel did, right? Intel sold off their ARM SoC business. And, they said, look, we need to focus. But it's always difficult to predict the future, I guess.
Yeah. Hindsight is 2020. I mean, everybody who's saying, "Oh, well, AMD sold off its GPU assets to Qualcomm." I mean, hey, that's hindsight is 2020, right?
AMD needed the money. It was only
they needed the money,
like $70 million.
And the thing is, their GPUs, they were ahead of their time, right? They were still selling into a market where you needed 140 different versions of Tiger Woods. Right, just to run on every phone out there. They didn't have the consolidated kind of platforms that we have today, where you could build a game for 3 different platforms and cover a good hunk of the market. And I think they just kind of viewed it as, hey, this is going to continue for a while. We have no faith that anyone's going to kind of pull everything together and build good mobile platforms. So let's unload this thing and use the cash for our business that's making money.
Yeah.
But Ryan, you skirted the question. How realistic is this? How bad is this going to get?
It's going to get worse before it gets better. The good news is,
will it get better? Like, is it? So you pointed out something that I hadn't considered, which is that the terms of the AMD Intel cross license agreement state that if there's a change in control of either party, so if AMD gets bought or if Intel gets bought, then that license agreement is void, right?
Correct.
So AMD no longer can make x86 CPUs.
If there's a termination upon change of control, the agreement is void and it has to be renegotiated. Now, this goes for both sides. So if AMD gets purchased, the complete agreement is broken, AMD loses access to Intel, and Intel loses access to AMD. So both have to come to the table to renegotiate. But of course, the issue is, in any kind of negotiation, it's Intel who has the upper hand.
Yeah. Well, it depends on who the new controlling party is, right? Like, I'm assuming, I don't actually know, I don't remember what patents or what license to patents that Intel got out of the cross-licensing agreement. But I would assume that these are things that Intel needs to continue operating.
Oh, yes, they do, absolutely. Intel basically needs AMD's patents for the 64-bit x86 stuff. All of
Oh
that
yeah,
is
that's
AMD's.
right. That's right. I remember that.
So yeah, I mean, there's if they do come to purchase and there is a need to renegotiate, there is obviously a need for Intel to come in there with honest intentions of making everybody happy, but still, you're negotiating with Intel.
Yeah. But presumably whoever if someone were to buy AMD, it'll be a company that's more Intel sized rather than one that's AMD sized. So it'd be a company that can negotiate, I would assume, or is in a position to negotiate.
Well, their size.
It could
You're
be
gonna have to offer Intel something.
an investment fund.
Yeah, that's true. Someone like ATIC that bought out AMD's fabs.
Interesting aside, these last couple of weeks, ATIC added another board member to AMD's board. What is it? It's 12-man board. Now 2 members are from ATIC.
Do you think is that significant? I mean, do you think that ATIC ends up being the one that saves AMD here?
I'm not sure if ATIC's going to be the one to save AMD, but I do think that's significant. To add another board member after all this time, right as AMD approaches their darkest hour, yeah, that's definitely significant. ATIC has a vested interest in, at the very least, keeping their major customer here in business so that they're using those expensive foundries that they just shelled out for.
So the question is, what happens from here on out? We don't, like, Charlie had that rumor that in this last round of layoffs that the GPU guys were significantly targeted, and on that call where they went over kind of what happened, AMD was unwilling to talk about who the target of the latest layoffs was. What does this mean for where AMD is today? What does it mean for AMD 3 years from now? Like, I'm afraid that, and I don't know how rational this fear is, but I'm afraid that development is being impacted now at this point, given the current financial situation.
Development is absolutely being impacted. They laid off most of their open source guys responsible for making the Linux kernel contributions necessary to maximize the use of Opteron. So, yeah. As for hardware guys, harder to say. But
well,
15%.
Take hardware. There's on the desktop PC side, we've dealt with the 9 series chipsets now. The 3 generations of CPUs with the Phenom 2s, with the bulldozers, and now the pile drivers. So they're not selling any more chipsets. They're not designing anymore.
That's true. And then Steamroller looks like it's been delayed now until 2014. Is that your take on it, Ryan, as well?
There are rumors going around about that. Obviously, the only people that really know are the people working with AMD, and they're not about to tell us. But the problem with these rumors lately is that they've been panning out to be true.
Okay. So what happens? I mean, what do you think? Is AMD going to get acquired, or are they going to somehow just kind of scrape on by? Because I feel like AMD, if you had asked me a couple years ago, what's the long-term goal here? Well, the long-term goal is, if you're AMD, you have faith that Intel can see this thing through, that they'll build a market for x86 tablets and phones, and then you can come in as a secondary supplier, right? Let Intel do battle with ARM, let that thing see its way out, and AMD, you just come in at the end, and now you have an alternate solution. These past couple of years have turned it into looking like that, hey, Intel is not making anywhere near the progress that everyone thought they would, or at least that Intel and maybe AMD internal thought they would. And now it's looking a lot more like, hey, ARM is going to have a fairly good stronghold in mobile going forward for the foreseeable future. And tablets are still unclear at this point. Windows 8, Windows RT, all very interesting, but not kind of the knock out of the park yet, to the point where AMD can really bank on x86 being its savior. So what happens? Is AMD able to survive during this period, or do you think an acquisition in the next 12 months or so is likely?
Well, boy, isn't that the big question? So, on the one stand, AMD still has lots of money in the bank. They have over $1 billion in the bank. On the other hand, because of the fact that AMD stock is getting pounded so hard, they can't borrow any more money. I honestly don't know if AMD needed more money, if they would have any way of getting more money. On the other hand, because Steamroller's probably delayed until 2014, AMD is almost in a holding pattern. The majority of their money is going to come from Trinity and their other desktop/laptop CPUs, GPUs, and the upcoming Jaguar products will of course play a part, but they're going to play a smaller part. Even a huge success there may not translate into a lot of money for AMD. So what?
Even with the billion in cash, even if they hemorrhage its current amount, that still gives them, what, 2-3 years margin before they run out?
No, it doesn't. That's the problem. It may not be enough to get them through the next year and a half, depending on how fast they lose money. And that's, and of course, that's contingent on just how well their sales go. If they have really bad sales, since most of their costs are fixed, they're going to go through money even faster.
So they need a killer product or a Hail Mary pass.
You know, that is pretty much what it comes down to, I think. If
But
we're taking,
I don't see. I mean, listen. I believe in their roadmap. I believe in their engineers. I even believe in a bit. I believe in their new management. Like I think that they have the right idea. The question is it too little, too late? But I don't think they can put out like a killer product in the next 8 months that's going to really change all of this.
yeah, and that's the issue. AMD has some very interesting strategies coming up, but basically it's all that gets executed on in 2014. Products don't come to market utilizing those strategies until 2014. If Steamroller's delayed, HSA doesn't become a reality until 2014. I don't know if we're going to see AMD be able to make it until 2014. If I had to take a guess on what's going to happen to AMD here, I think there's a most likely outcome is going to be that potential suitors wait for AMD to burn itself out, maybe try to push the process along in order to pick up parts of AMD in a bankruptcy sale.
That's like a horribly depressing outcome.
I know it is, but
or
let me.
yeah, they wait until it's very cheap, and then a chip designer with backing comes in with a good idea, gets a couple of years worth of funding to go design his chip with the AMD hardware and team, and then maybe something comes out of that. But then that stagnates the Intel side on the desktop for the next couple of generations.
Yeah, I mean it's not. Just
I mean, the
about
best target for someone like that would be like Samsung, right? Like they've got tons of cash and they're clearly interested in being very vertically integrated. But the issue is for a company like Samsung, do you just try and buy AMD and deal with all the overhead or the fact that you'd have to lay off a bunch of duplicate folks, or do you just hire their engineers?
You just hire their
Ryan,
engineers.
you were talking about how Qualcomm now has an office just down the road from AMD in Markham, where all the old ATI folks were working. And I know AMD proper was trying to get everyone to kind of consolidate in Austin at the new campus. And there were a lot of folks, working at ATI, now AMD in Canada, that just didn't want to move. And, Qualcomm says, hey, look, here's another solution. You can just stay where you are and just, come in 2 buildings to the left of where you used to come in, or I guess to the right. And here you go. Which is even worse for AMD if people just continue to poach their folks.
Yeah, so that's the big problem right now is if you really want an AMD engineer right now, you don't have to wait for them to go into bankruptcy. It's going to be fairly easy to poach AMD's engineers. Qualcomm, of course, wants to pick up AMD's GPU engineers. They're going to have a very easy time of it. They're not 1,000 feet from AMD's offices with the Tim Hortons in between. So if you're an AMG senior engineer, you walk out for your morning coffee and you just keep on walking over to Qualcomm. But
yeah, I don't even like having this discussion because AMD has been such a key part of the evolution of the PC industry for so long. But I don't know. I am worried at this point.
Yeah, really, you can poach all the AMD engineers you want. So if you were going to purchase AMD, you weren't buying AMD for the engineers. You'd be buying AMD for the patents.
Yeah.
And
well, now, okay, let's look at the flip side of the coin. AMD came out with their official statement is we're exploring options and we are not pursuing a sale as one of those options. If we assume that's true, what are the other options?
Could they be just selling parts of the company?
Well, so here's the issue. What would they sell? They've sold off the fabs. They can't sell off the GPU division because they need that for Fusion. They can't sell off the CPU division because, well, that's AMD at its core right there. They could sell off some patents that aren't tied up in Intel agreements. Maybe get some cash out of that.
Garage sale.
But again, if we take if we take the sale off the table, right? What are their other options?
Well, they've called in JP Morgan, haven't they?
Yeah.
Maybe they're telling JP Morgan, go find some disgruntled engineers at company XYZ and see if we can bring them on board.
No, I don't think so.
Yeah, but what's that going to fix? I mean, like, the roadmap is the roadmap.
Yeah. And the roadmap's not bad, right? The issue is, can they survive in the market until then? Until the roadmap has, time to take hold.
It's definitely dire.
I don't know.
I don't know what other solutions there are. Obviously, like, there are a lot of people who are thinking about this.
Yeah.
Who are... I'm not well appraised at AMD's internal stuff, so...
Well, you guys are going to find out more at CES, and there'll be even more insight by the time Computex next year comes along.
Yeah. Well, I just remember when we heard the first rumors of an AMD ATI acquisition, and I'm kind of... I'm waiting to hear that now, right? But there hasn't been anything concrete. I don't know. I don't like any of this discussion. I hope it doesn't turn out this way.
We need
I just don't know.
But if it does, then what happens?
Well, I think, on the client side, ARM is the new AMD. I think ARM is there to keep Intel. Now, AMD was the element that kept Intel very performance focused. ARM is the element that keeps Intel more cost conscious, and it keeps Intel more power efficiency conscious. And I think that's a very good thing. I think we already have that in the client space. Should Intel try to stagnate, ARM has no issues coming in and trying to get into every single form factor that exists. So I'm not worried about that. At the high end, yeah, that's still a problem. We don't have much of a threat there. In the HPC space, non-issue. NVIDIA's got that covered. But if you look at kind of that beefy high-end, very high-end desktop workstation and kind of beefy big core enterprise space, Intel has no real competition there. And they won't for quite a while, it seems.
One of the points that you came up with the other day, the fact that if AMD does get sold off, the US government's going to come knocking on the door for monopoly issues.
They might.
Yeah, that was Ryan's point, actually.
It's obviously not guaranteed. If this was 10 years ago and AMD disappeared in the middle of the night, yeah, the US government would be there the next morning to break apart Intel with pry bars if necessary. Right now, I don't know. Intel would basically be making the argument that ARM is the necessary competition. On the other hand, x86 still powers most of the world's computers. So obviously you have ARM in the tablet space and the phone space, and that's big in terms of growth, but in terms of computers that people rely on day in and day out to get work done, those would all be powered by Intel.
So they're above the law for a little while, potentially.
So Ryan, I got a question for you. Going back to the "hey, did we make the right decision" type of thinking, should AMD have sold off its fabs?
Boy.
Because I feel like that's if I'd be feeling a lot better about AMD if it had Dresden under its control right now.
If AMD had Dresden under its control right now, we would be talking about AMD's immediate bankruptcy sale, most likely. those
Interesting.
fabs.
So you think they wouldn't have been able to sustain it? I mean, because
Those fabs are losing
those
too
fabs
much
weren't
money.
bad.
That they
right?
aren't bad fabs.
They
no.
were having difficulty keeping them kind of occupied with, their x86 silicon. But I feel like they still give them, those fabs gave them leverage in the market, and they gave them more of an ability to play around with the cost of their chips.
They did, but they just were too expensive. I mean, AMD's history getting rid of those fabs is just one write-off, one loss after another. With ATEC ownership, I don't know if we have access to the relevant financial documents, but I would be surprised if Global Foundries was making any kind of profit right now. Fabbing is hard. It's very expensive.
So you think they, Dirk and all, they made the right decision back then?
They made the only practical decision they could have, which was to get rid of the business that was causing them to lose money hand over fist.
Okay. So then, all right, let me ask you this. So we don't have to have another hindsight question in a couple of years. What is the right move today? If you were, if everyone on this podcast now became in control of AMD, what do we do?
I don't have a good answer for that. I really don't.
Apologize for Bulldozer.
That's
right,
not...
right. I mean, come on. This is like their execution was bad, and they should feel bad, and they are feeling bad, right? And at the same time, like Ryan, I understand that this is still a primarily PC site, and this is still a primarily PC audience. But like Windows 8 happened, right? The desktop is taking a shift away from x86, or at least now it's an alternative. So this is like a strategic thing, and whether or not the industry goes one way or the other is very much up in the air right now. And again, if you're a player and you have no compelling strategy there, right, and your traditional execution already is like I'm talking about the PC desktop side. Execution there is already suffering. Who are you going to go with, right? Like, I'd be very concerned. I'd be sweating bullets, right? I mean, these are just things that happen, right? Like I don't know. That's what I would say.
Well, so Brian, one thing I'd say is I think our audience these days is kind of an amalgamation of everyone, right? I think like everyone who's here today, I think we have interests across the spectrum in terms of compute. Whether it's ultra mobile or desktop. But my question to you is, so let's say you're the new head of AMD. What do you do? What's the first thing you do? You show up on day one in Austin.
We need a Clover Trail, basically.
Okay, so you come in and you say our top priority is a tablet SoC.
Yes, because that's the future. I mean, and then you can just scale up from there.
Okay. But what do you do about phones? Do you stay out of that, or do you just say tablets and above is what we care about?
I would do Intel's execution right now. Phones, I think phone is still arguable. I mean, Medfield is marginally successful. It's not. It's more of a just to like take us seriously. We're gonna make sure we have like some presence in this space to start curbing the perception that you can't have x86 in a phone. But the place that obviously that architecture is going to win with Clover Trail is in all these tablets and all these other things. And then it doesn't take very long to start plotting a course where, okay, we can deliver a power profile that's very appealing, enough performance to get things done, because most people are not doing scientific computing. Like most people are. It's the reality, right? At the same time, it's kind of like it's the dirty word is, performance is good enough.
Yeah.
Right. But it is good enough, and that's sort of the case that we're in right now. And I think that AMD is in this position, at least somewhat, because they were always going towards being the high end, competing with the highest end Intel SKUs, right? And at the same time, you need to compete on the low end. And I mean, I don't know. I'm not in charge of making AMD's, strategic planning.
Well, no. I
think you need to execute on what you can execute well on. And what AMD was executing well on was not where the market went.
Well, so no, this I think is a great point, though, right? You said if so Brian Kluge becomes the next CEO of AMD, you come in, you say we need a Clover Trail competitor. The only thing that I know of that's on AMD's roadmap that is actually going well according to schedule is Kabini, which would be their Clover Trail competitor.
Interesting. Well, that's good.
Right? Like that is the only chip that I know for sure is not going to show up super late is that. And if you're saying that if you show up tomorrow, that's what you do, well, then I'm a lot more comfortable now, right? Like I don't want to see. I don't care if AMD is no longer competitive at the high end desktop, right? Let me I guess make that clear.
I don't think investors are either.
Yeah.
I think they're looking at, is this going to be a competitive asset going forwards in this market that's now primarily dominated by things that aren't necessarily the highest end SKU.
Yeah. But if you're and then the next question then becomes, would that be enough, right? Could a Kabini win in Windows 8 ultra portables and tablets and stuff like that? Would that be enough to kind of float AMD going forward?
I mean, I don't know. That's a gamble.
Yeah.
Right. I think the same thing. I mean, same thing could have been said in a discussion in NVIDIA. Right. Is Tegra going to be enough to keep us going forwards? And everybody's kind of glancing around the room, like, well, is it? We don't really know.
Yeah.
So, but at the same time, they're where they are. AMD is where they are.
So that's interesting.
Hindsight is 2020. If I were them, I would be like, let's have an SoC. Because that's the way things are going, right? Even Intel reorganized.
Yeah.
Right. This is the emphasis now. And that's just the reality of like whether it's good or bad. I don't really know. I'm just calling the shots like I see them.
No, that is a far more positive perspective because, like I said, the one chip that I know is doing all right is their SoC, their first full-blown single chip solution. That one's on track. I don't know if it's good, but that one will come out on time.
Wow.
And see, the thing is, the issue is you need both, right? You need that strategy, but you need an enterprise strategy because no one is going to be able to survive making $20 chips. And for every, X number of phone and tablet users you have, you need X number of big servers to kind of support the infrastructure. So that's kind of a way of double dipping, right? That's why Intel's been able to kind of keep making more money, even though they're not present in any of the like really high growth markets, because they've got all of this great Xeon business coming in.
That's true. Yeah. So I don't know. My caveat is I don't know anything about enterprise.
Well, so then the question is,
I'm coming at it from consumer's perspective.
So then the question is, what is AMD's enterprise strategy? This whole ARM business is interesting, but everyone seems to say that the microserver market is at most 10% of the total enterprise market. And AMD, NVIDIA, and Intel, and all of the other ARM guys are all looking at that market. So you look at 10% of this huge market carved up 3 to 5 ways. I don't know that alone is going to be enough. So I'm not entirely sure there either. And that's one area where we do need to see Opteron do well, right? Because the ASPs are higher. The room to actually make money is higher there. There's definite concern on that front. But
so what is their market share presently in that space anyways?
Sub
enterprise
5%.
there 5% or something like that?
Yeah.
It's single digits.
Wow.
Am I wrong?
Like, so they're really hurting now.
Yeah, they went from like not terrible to they're very, very low.
They basically haven't been this low since before they had Opteron processors.
Yeah.
We'd have to go back to the very first Opterons when K8 came out.
So the way I look at it is there's not much more room to fall, right? It's easy at this point if they have something that's just not terrible to kind of climb up a bit. But that would be steamroller based, right? Like PileJava alone is not going to solve that. And Haswell based servers are supposed to be really good as well. So AMD can continue to compete on price there. And there's more room to kind of play around with price. But their power profile has been a real problem. And in the data center, everyone's power limited. So that's a major concern. But at least on the consumer side, it's good to hear Brian, I like the perspective, because and I hope that's what ends up mattering, right? If all it takes is for AMD to have something competitive in the SoC space, that there's chance there.
I mean, I don't see why it wouldn't. I think AMD has had APUs for a while now, right? Hopefully Kabini is successful. I don't know anything about Kabini, so I need to read up. But I think if we're talking about like stock price and investors making their strategic plays and calling shots, they do want to see execution there. And even though AMD has had APUs for a while, for whatever reason, it just hasn't made enough noise.
Well, they've also been like, so my understanding is this is going to be like a true single chip solution.
Yeah.
So it'll, like, those APUs were still effectively normal PC chips. They weren't all that great in terms of power consumption either, right? Like they haven't been.
But this will bring it like Clover Trail. They're saying
that's the hope. It'll be able to fit into Ultrabooks, right? And
wow,
that sort of form factor. And that's my understanding. Correct me if I'm wrong, guys. I don't have Kabini yet.
I hope that's the case, because that would be awesome. I mean, Intel needs competition. I mean, competition is good, right? But at the same time, the natural course of competition is sometimes players disappear when their competition isn't very good. And I mean, what are you going to do? I don't know. That's not really my problem,
yeah.
Right?
Yeah, no. So Kabini is supposed to be the it's the Brazos successor. But single chip SoC, so it should be a anywhere Atom can go, it should be able to go.
That's awesome,
and it's 28 nanometer, like it's modern process at least. So I don't know. AMD at least internally seems very excited about it. Maybe that ends up, and it would be amazing if that ends up being their chip that kind of turns things around. The issue there is if your chip is an SoC. It's not just the SoC that matters, but you need to have real design wins. And that's a whole nother ball game. Because if you look at where Intel was strong with the Windows 8 launch devices, as far as I can tell, the best Windows 8 launch tablets and notebooks have been devices that Intel has gone in and helped design with the OEM. And right, like you look at the Acer product stack. And the S7 and stuff like that, the devices that look cool are devices that Intel went in and helped design, out of just pure concern that if they didn't, things wouldn't look so good. So I'm obviously worried about that as well.
I mean, obviously they need all the tools to make it a success.
Yeah. So switching gears to another somewhat depressing topic, TI officially announced that they are exiting both the application or just the general, their wireless business, as far as we're concerned, the things that go into smartphones and tablets, they're winding that down.
And 1,700 jobs with it.
Yeah, no, it's not good at all. But it's bound to happen, right? One of the first things we all started talking about when we really started getting into mobile, which was, that there's going to be consolidation. I don't think any of us could have really named which ones would go out of the kind of strong competitors at the time. Because TI at the time was talking they were in a very good position with OMAP 3 and OMAP 4 on the horizon. It seemed like they were executing really, really well.
I had TI at the top of my Deadpool.
It's just a very low margin business.
Yeah, and OMAP 4 was everywhere, and OMAP 3 was everywhere before. It was like you couldn't turn over a rock without finding an OMAP 3 or 4 somewhere.
Yeah.
I think that what makes me really sad, even though I have no invested interest, I was thinking about this yesterday, is that I'm not an industry insider at all in any of these companies, and I have no vested interest with what player wins or whatever. Like I read comments and they're like, oh, well, he loves Qualcomm. I'm like, no, I don't. And previously it was like, oh, he loves TI. No, I don't. So the thing is, like, TI was always very open, and of all the SoC players, they're the ones that kind of gave us our start. And I would say that there's no question about they gave me the start in terms of they were the first that like had documentation on their website that I could read and like talk about like here's what's in the SoC, right? And So from that perspective, it's a loss because the remaining players are just nowhere near as open or nowhere near as like open to disclosure, and everybody should feel bad for that. For the rest of it, I mean, obviously TI has sort of made this overarching decision to become an analog company, and that's been the name of the game for like 2 or 3 years now. So this is not surprising at all.
Yeah.
So they're becoming an analog company, and obviously OMAP is not analog entirely. It's a driver of sales of analog is how they view it, and so that happened. And but at the same time, if you look at all the talent, like what I look at, who are the really influential people that are at these other companies now, like Qualcomm, like Samsung. All of them came from TI, which is just fascinating to me. Every time that I meet somebody that's like an engineer or a chip designer, or like I don't want to say Raj at Qualcomm, but he's obviously one of them. They all came from TI. And so it's just kind of unfortunate, and I think they made the migration a long time ago, and everybody knew that they just wanted to become an analog company.
Well, so it's really hilarious that you mentioned that, because I remember having dinner with Carol Killebrew, formerly of ATI and AMD, and he also came from TI. And he laid out a vision for me where if they had gone a slightly different direction, that TI would have been a major player in the GPU space. And I hadn't really even thought about that until this, right? Yeah, I wonder if this is a similar type of situation where TI could have, easily been the dominant player in the mobile SoC space, but it's not the direction that they want to go into.
Yeah, even the Samsung semiconductor guy I talked to, he was from TI. So I mean, it's like everybody, all roads led from TI, but at the same time, it's like they're not at TI anymore.
Yeah.
So it's obvious to me that everybody sort of knew that they were going to become this analog company, and that's just the reality of what happened. And at the same time, there's a lot of discussion in here about concentrating on embedded markets, and that sort of has always been the case. Like the OMAP SoCs eventually just become things that end up in embedded SoCs. Like the IP gets reused. Like my good example is the and the Nest. We someday we'll talk about the Nest. There's a Satara AM37X SoC, and that is essentially just analogous to an OMAP 3. Like it is an OMAP 3. In fact, you can buy a Satara AM37X that basically just is an OMAP 3, or one with the SGX fused off. So, I really wonder, like which one is feeding which. And as a result, how much of this is, we're just going to focus on embedded. How much of this is we just don't want to do anything with this at all?
Yeah. No, it might just be that that's what TI management knows how to do, right? They're really good at embedded, and this other space is insanely competitive. You have to market a lot, right? There's a whole lot of like customer relationships and management of the whole business that just doesn't exist elsewhere. The cadence is also a lot more aggressive. The stakes, if something goes wrong, are a lot more public in nature, right? Like
yes.
We haven't seen that yet. Like we haven't seen someone have a big silicon screw up in Ultra Mobile yet, but that's going to happen at some point. and that's going to be a very painful situation for whoever it happens to. I totally, if you look at it this way, who would want to be in a market where your chief competitors are Intel, Nvidia, and Qualcomm, right? Like that doesn't sound like fun at all, right? Like that's
not me.
Exactly.
I like the line in that release though, that it was like where customers are increasingly developing their own custom chips, because you see a lot of these players kind of doing that though. Like Huawei was a TI customer for a while.
Yeah.
But now they have HiSilicon. So like they just realized they could go and, for the cost of the license, buy all these things, drag all the blocks together, hit go, synthesize a design. Okay, it works well enough.
Yeah. I think I do still believe that is short-sighted, right? I think you are not going to be able to compete with someone who, at least let's say mid-range to high-end, You're not going to be able to compete with someone who's integrating, tier 1 silicon, like someone who's just shopping at Qualcomm.
Yeah, no, I totally agree. But I mean, I just found that interesting that statement kind of reads like both they're spending lots of money making like their own custom CPUs,
Yeah.
and they're spending lots of money just sort of like, well, we can make an SoC too, and it's going to be even better suited to what we want.
Yeah. Well, I think that also kind of, you hit it perfectly with Huawei. That perfectly sums up TI's customer base, right? They are the kind of they were the lower tier customers who might consider building their own. They weren't the HTCs of the world, right? Who were shopping at NVIDIA or at Qualcomm. And as a result, if their existing customer base is looking elsewhere, then that doesn't bode well for them.
Yeah, I think, well, Motorola obviously was a big driver for a long time.
Yeah.
And I don't know what's going to change under the Google ownership path. Probably nothing. They've always kind of like migrated to whatever they want.
Yeah.
But for the longest time, it seemed like it was all OMAP. Yeah, and then the volume pricing stuff, like it's unbeatable. And then you were mentioning earlier that something I hadn't even thought of is, does this mean that they're also exiting all the combo space? I don't really know. The wireless connectivity solutions, that's kind of scary.
Yeah, exactly, right? Like it's Broadcom's really strong in that space. That's another. I mean, I was just never none of the competitor lists that TI had in this space sounds at all fun, right? Like it's all stuff where I'd be like, okay, I'm just gonna make donuts somewhere for a while. Like this is completely uninteresting to me.
Yeah, well, and Broadcom is entering the SoC space very aggressively too at the low end.
Yeah,
and so that's going to happen. So I think all those cards definitely aligned, and what we see is this end result. But it's unfortunate again because they were the most open, at least in terms of like, we're going to answer your emails and have like a PDF where here's all the GPIOs, here's all the in-outs. No, nobody else does that. Like if I find a pinout, it's just like something some engineer has leaked.
No, that's true, and I still do believe that that's going to change. I think we will probably have to see one more company go before we start seeing people focus on doing things the right way. But I am confident that that'll change.
So let me ask:
that more people will have pinouts on their PDFs?
Yeah, I think you'll see the same level of detail, right? I look at the golden standard for me is the fact that I can pick up like an x86 architecture reference manual and I can get things like execution port details and register file counts and stuff like that out of Intel. I view that as the gold standard, right? And well, if Intel's a player, I do fundamentally believe that at some point they bring that top to bottom because that's just in their DNA. Now I look at Qualcomm and I see a company that is being very influenced by Intel. And I see them following the same footsteps, that they are going to start opening up because they do see the value in doing that. And if they're going to be a leader, I think they can. There's extra value in doing that. So I don't know. I have hope that people will start doing more of this. It's just we're not quite ready yet.
Yeah, I don't know. I worry because the consolidation means that there's even less emphasis on like, hey, we want to disclose all of our details.
No, I view it the other way though, right? The consolidation, you don't want to show everything that's out there when you have 7 different entries of being attacked from, right? But if there's only like 1 or 2 competitors and you know what kind of cadence they're on and you know how they work and how they develop, you're not exposing yourself to that much risk if you have a controlled release of information. And if you know what you're doing from a marketing standpoint, a controlled release of information can actually be very, very good for swaying kind of public opinion of you. So I don't know. Maybe I'm the eternal optimist, but I do believe that we'll see that change.
I don't know what. Yeah, I don't know what to say. I think it could go both ways. I'm more and more pessimistic about any players opening up unless we just continue hammering on them.
Yes,
and other people continue hammering on them, and I mean, we'll see.
So speaking of mobile, you just finished your Nexus 4 review, and I know you wanted you talked about that a bit on the last one. Is there anything you want to add to your discussion of it?
So when I discussed it previously, I think I was still pre-embargo and I was in that mindset. I really liked the phone. Obviously, like we hit go and there's sort of a hyperbole. There's a lot of hyperbole at the very end about how good it is and you should just buy it, which I heard about from emails. But of course, that was written after being up for 36 hours. So I don't know what exactly was said there. But I wanted to discuss really the fact that there's a disturbing trend emerging, specifically in the camera, and that's of presenting a UI that crops the 4:3 aspect ratio CMOS down to just whatever the UX designer decides looks good, and that needs to stop right now. And that started with the iPhone 5, and it continued on to Android with the Nexus 4. So into AOSP, this is the canonical camera application design that you can implement if you're, just building a straight ROM, and that just needs to stop. And I will fight it until my dying breath, just because it is completely wrong, and there's just so much that makes me infuriated there.
Wait, so just so people understand, what is exactly happening, right? You're getting a preview on, like, when you launch the camera app, and what's displayed on the screen is a different aspect ratio than what's actually being captured?
That's right. So all CMOSs most CMOSs are 4:3, at least in the smartphone space. But I mean, they're a much more square aspect ratio in general, because when you form an image, you form a circle. And what's the best way to sort of fit a square into a circle? Well, it's sort of that square aspect ratio, right? I mean, you want to use as much of your image as possible and just not waste all of this good space that you've spent a lot of time designing, your system to not be aberrant in. So CMOSs are 4:3, at least in the smartphone space. And obviously, display viewports are not very square aspect ratio. They're like 16:9 now, so 16:9:1 basically everywhere. And the Nexus 4 is, of course, 15:9 with that 1280 by 768 display. So if you're designing a camera UI, you are confronted with this problem where, well, if I display the aspect correct version of what I'm reading off of the CMOS, I'm going to have like pretty big, ugly black bars. Like a sizable chunk of my display is going to be just nothing.
Yeah.
And there's a temptation to just go ahead and do that, right? Which is the temptation that Apple gave into, sadly, which previously they had been like sort of the purists, in that, you got a very high resolution preview with good FPS, at least on the phone. Personally, I think the iPad FPS is terrible, but they've made a trade-off there to have high res. But for whatever reason, now these other OEMs are deciding to do the same thing, and it needs to stop, because when you're taking photos, composition matters, right? Like, I can't believe I'm even needing to say this, but
well, so okay,
right
on the iPhone, what the way Apple gets around it is they put the controls in that portion of the screen, right? So it's not black bars.
That's right. Well, but I mean, it's still just like wasted screen.
Yes.
And there would be even more wasted screen had they decided to actually do the real 4:3. So it's like 3:2. It's approximately. It's not even like anything useful. It's like approximately.
Yeah. So how does the Nexus 4 work? What do you see on the screen when you're taking a camera?
You see a center crop that corresponds to it's not even 3:2. It's like something weird. Like, I gave up. If you look at my ISO 1233 images,
yeah,
I literally just threw my arms up. I spent an hour trying, and then I said, you know what? If you're gonna do this and you're gonna make a camera that I can't use like a camera, then I can't be bothered to take photos that mean anything to me. No, literally, and that's the end result. And I think I wrote that in the review too, is that, like, if that's what you get, this is how close attention you're going to pay to making your UI, then you just don't get evaluated. Like, it's impossible physically for me to align the thing to get, like I guess and checked, like moving the camera in slowly, getting close to aligned, like it's very difficult without an optical bench and a table
Yeah.
to do those photos. And it's even more difficult when I'm being presented isn't actually what the camera is taking pictures of.
But if they're doing a center crop, they're showing you at least the middle part is accurate, right?
That's right.
Why is that not enough to line
The
up?
fiduciary marks in the ISO 1233 chart are at the edges.
Oh, okay.
Like if you look at those pictures, there's markings all along the sides that have different aspect ratios, like they're 16:9, 3:2, etc., etc. And what you do is you put, the way that works is it's line pairs per image height. So it's referenced to the size of like your viewport. And so you need to get that aligned, otherwise you're just measuring nonsense. And so ultimately I just threw up my arms and was like, well, fine, you're going to get nonsense values. Like, I'm just not going to take you seriously, because you're not taking it seriously. And I actually really regret doing it for the iPhone. I very much regret objectively measuring their camera and calling out, here's how many line pairs per image height you resolve.
Yeah.
Because frankly, it does not deserve to happen. And it's just like, I'm not okay with this.
So what's the
And
solution? What do you?
The solution is you do a double tap and then I get the aspect crop. Give me an option to do the correct field of view.
Okay.
For like people that care about how I'm gonna take a picture. Like this is not a thing. This is not something you can waver on. Like when you're buying an expensive DSLR, one of the figures of merit is how well does the viewfinder represent what I'm gonna capture onto my film, or in the case of a DSLR, on my CMOS.
Yeah.
And that's why you see numbers like 99% viewfinder coverage, or like you move to the really high-end stuff and it's like they add another 9.
Yeah.
And this is why the mirrorless cameras are cool, is because I don't have to worry about that. Like what I get in the preview is really what I'm going to see through the lens. And this is also why SLRs were cool, right? Is because I don't have a secondary viewfinder. Like I'm looking through the lens.
Yeah.
So to see people just throw all of that away, and then like some UX designer is like, oh, it looks cool. That just really, really, really makes me angry. Like I think I tweeted the next phone that does that goes against the wall. No, like it just makes me very angry, and it needs to stop now. So I just wanted to say that. That's everything else about the phone is great. That just makes me very angry. and also the thermal throttling stuff is what it is. Maybe someone will fix it. People that are asking, is it hardware, is it software? Obviously, it's a combination of both, right? You need hardware to heat up so that software can kick in and thermally throttle the thing, whether that software is embedded on the SoC or controlled by the daemon that I called out and showed, like, here's the paste bin, here's an XML file, like, go edit these values. I mean, I've answered the question, so there's nothing more that I can say about it.
Yeah.
So that's that. That's Nexus 4. It sounds terrible, but yes, this needs to stop. This camera UX nonsense.
Well, that's good. I know at least I feel like if you take this feedback to... Actually, I bet you if you go to LG, they'd listen to you right away.
Well, LG implements their camera correctly, right? The thing is the AOSP is wrong.
Okay.
So like some UX designer at Google was like, hey, well, this looks cool.
Now, hang on.
I'm sorry, that's not how you design a camera.
Did you tell Google this? Have you emailed our Google dude?
I emailed, so we're supposed to have a discussion at some point. Yes.
Okay.
We're gonna get on the call and I'm gonna initiate. But I mean, I've said all this, right? Like I sent him a link to my review. We'll see what feedback they have. I've never heard anything from Apple. That's what really gets me too, is that like we published our thing like a month late.
Yeah.
People already thoroughly reviewed the camera. I'm doing air quotes, thoroughly reviewed the camera. and yet I'm the one that has to sit down and discover that the preview is a lie, right? Like what have you guys been doing? Like, and then the grid, right? The grid, so like the grid that it projects isn't even useful, right? Think about that for a second. Like they have this grid, right? The new grid mode.
Yeah.
You do options and it's supposed to help you compose because it's like rule of thirds. That's not even right. That's not the rule of thirds. What you're showing me is not. Like, why do I have to make these observations? I thought Apple was the one that was like hyper attentive to detail. Yeah, I get angry about this kind of stuff. Like,
no, I'm looking at the grid mode now, and you're right, because it's a grid, but since this isn't the actual, like, this isn't what I'm capturing,
exactly.
It's meaningless.
It's totally meaningless. So, but why do I need to? Why am I making these? Right? Like, and when is it getting fixed?
Yeah.
Like, it didn't get fixed.
Well, you know,
it's
the way I look at it is like this. One, this gives you something to rant about, which I think is hilarious. And two,
no, and people were like, it's hilarious. It's not something average Joe is going to notice. But I mean, like, the future of camera is something that's like a smartphone, like Galaxy camera.
Yeah.
Like some connected device that you just have on you.
Yeah.
And if we're going to throw everything away because it looks nice, then you're doing something really wrong.
Well, that's the embodiment of this entire mobile revolution, right? We have made that exact sacrifice so many times, right? Where people are like, well, it looks fine, so that's all that matters. Like, I don't see this kind of pervasive focus on, well, let's do something that's technically right. It's just it's not been a part of the DNA of this whole evolution as we've been covering it.
Yeah. I don't know what. Yeah, there's a lot of like. This is again, the PC space has always had this very good attention to detail.
Yeah.
The mobiles, and that's what's great, right? So I mean, like, I don't want to come off sounding like this is all horrible, but what I want is that same level of attention to detail in this, like, we're going to be computing on these things for the foreseeable future.
Well, so that's
like 5 years ahead.
That's what is always interesting to me about convergence, right? I remember when people were talking about digital convergence, that the TV was going to get more intelligent, and then you were going to be able to get more content that you would just have on the PC onto the TV. So people said, well, you know, the PC industry and the television industry, they're going to converge. And if you look at that as like a horizontal plane where two entities come together and they both pour into this like final converged entity, that's the wrong way of looking at it. What ends up happening is you have one more powerful entity that adopts the features of this other entity that's being converged, and it's the more powerful entity that ends up kind of determining how it works out. And it's the reason that we have things like that, we got stuff like Roku or the Boxy Box and stuff like that. Those are all born out of PC-based architectures. And as a result, didn't make the same mistakes that, you know, if you had a TV manufacturer doing this, those mistakes that they would make. And I view it the same way with this mobile PC convergence that's happening. I feel like at the end of the day, the companies who have had the experience and have run into these issues and know the right ways to solve them, those will be the ones to play a significant role in whatever the converged device looks like.
You're absolutely right.
That's my hope, right? Because things don't converge equally. There's always a dominant player, and as long as the dominant player has experience in building, you know, sophisticated computing devices, I think we'll be okay. I think what we're seeing now is you have a lot of players in the space that, one, they have no experience building computing devices, none, right? Like, a lot of these guys still come from the, like, building things that had a dial pad with maybe a little screen, right? Like, that was they were good at that. And now they're building a computer, and that doesn't necessarily map one-to-one, right?
Oh, yeah, obviously, yeah.
So I think there's
a lot of learning that needs to happen.
There's a lot of learning, and if it's not, like, I fundamentally believe, if you have not screwed up and had to pay for it, then you're not going to do the right thing. Like, it's not going to happen. It doesn't naturally come to you to do things a certain way until you've done them the wrong way, and then realize, oh, this was really bad. Everyone got really upset at me. And I think that's one of the reasons I really appreciate, you know, when we have a situation like this where it drives you off the wall, because that's where we get that learning process from. Right now, things can get better. The concern I have in the tech space at this point is, and you and I talked about this recently, in the old days, you had people reviewing PCs and people reviewing components, and there was not much crossover. And as a result, you didn't have people reviewing components and they didn't really get the point and didn't write it off for no good reason. Here, in this ultra mobile space, everyone's reviewing the same stuff. And I feel like that's why we end up with such a wide variety of opinions on things like the Nexus 4, because you have people coming at it from two different angles.
Right.
You have someone looking at it as, why isn't this the iPhone? And you have someone like yourself looking at it as, hey, this is a totally legitimate player. This is the type of user you have to be to want it. And that's the only aspect of this that worries me, right? That we won't get the kind of negative feedback that you're providing here about this particular feature that honestly these companies need to be better. I don't know, to have gone down the wrong path, failed for it, and be punished for it to do better in the future.
Well, obviously, yeah, the level of criticism, and I don't want to sound like conceited, but the level of the criticism that's out there of these platforms is generally quite like basic. You know, it's not an iPhone. I'm still reading this, right? Like it's things that I still read.
Yeah.
And it's gotten better, but yeah, at the same time, it's not like let's critique the low level things that need fixing. You know, like let's offer a critique of like, what is the user interface design that's terrible about this?
Yeah.
You know, and by the way, that's the other thing too, is that I got the OTA, like people that other reviewed the Nexus 4, they reviewed a pre-release image. I reran everything on the release ROM, like in the last, like that got pushed live. Okay. Then I went to go stand in line for Call of Duty. Then I like worked for the remaining like 12 to 16 hours, right? And then hit post. So like the time that people had with the final image was, you know, that I had at least, was like on the order of 12 hours. So, you know, it's difficult to finally review something when things are going to change. And that's why I didn't make a big deal about this previously. You know, it's when I came across it, like finalizing all my review components, that I was like, well, now I'm going to scream my head off about this, you know, and at the same time, I have to offer praise that the other parts of the camera experience that I identified as being terrible were fixed. Like the video that was just dropping like 30% of its frames, that's fixed. Yeah, actually 30% of frames were dropped previously, so that's fixed now. And yeah, I agree. I don't know, honestly, yeah, there needs to be like a lower level critique of these components and, you know, like just details in other reviews if we're going to move the industry forwards. And this is what we're going to be computing on. That's what, and I'm saying if this is going to be what we're computing on, right?
Yeah.
Like, do I want to be computing on something where I'm just like making design decisions because it looks pretty?
Yeah.
And no, like it's a rhetorical question. Of course not. That's a terrible idea.
Exactly.
This is horrible. So please stop doing things because it looks good and it sacrifices like functionality, like all the functionality. You know, like I don't know how anybody can use the camera and not, like I don't even compose. I just like, why even present a picture? Right? Like if I were actually sitting in the meeting, I would say, why even bother presenting the user a picture if you're going to just lie to them? I would go that far. Like, let's just go all the way back to the Stone Age, like that, you know, dot matrix Nokia phone with the like smiley face. You know what I'm talking about?
Yeah.
They did facial recognition and they would give you like a frame and then like here are where the faces are relative in the frame.
Yeah.
You know, like if we're going to do it, just screw it. Let's go all the way back. So, anyways,
all right. So that's your final take on you've said your piece on Nexus 4.
I said my piece, and it needed to happen. I feel so much better now.
That's good. I'm glad. I know you also got Nexus 7 3G. I want to, you know, we're past the 2-hour mark. I want to hold off on that until next time.
Yeah.
But any final words or comments from anyone out there? No, I think we're good. Okay. I want to thank everyone for listening.
Is everybody asleep? Did Ryan and Ian, what happened?
We're here.
I think they're in awe of all the camera discussion at this point.
Oh, okay.
Okay. Anyways, I want to thank everyone for listening. Check out the site. We've got tons of content going up, tons of things that have gone up. And looks like there are hopefully no more major launches between now and the end of the year. But I know that means for me, I'll be playing a lot of catch up on things that I've been wanting to get done. So until then, we will hopefully be back in a week. And thank you for listening.